everyone, welcome back to Pepcoding. So the question which we will discuss today is called negative weight cycle detection. First we will understand what to do in this question and then we will understand how we will move over to it. Okay, so what you are doing is that we have been given a directed graph, and in this directed graph you have to figure out whether there exists a negative weight cycle. Now, the first thing you need to understand is that there is a difference between a negative edge weight and negative weight cycle. A negative edge weight basically is an edge which exists between two vertices whose value is negative. So, for example, -5 over here is a negative edge weight. Alright. On the other hand, a negative weight cycle is the one, the sum of whose edges or the edge weights comes out to be negative. Okay, for example, in this case we have 2 plus 3 plus -4 plus -5, which will give me -4 as my answer. So the sum is -4, which means it is negative, obviously. So it is a negative weight cycle. So this is how you need to figure out whether there exists a negative weight cycle or not. Okay, if there exists a negative weight cycle, you'll return 1, otherwise you will return 0. So what we are going to do is, we will use Bellman-Ford for this question. Alright, so if you don't know what Bellman-Ford algorithm is, I'll suggest you to go and watch the previous video, which is for the Bellman-Ford algorithm, because this question is an application of Bellman-Ford. If you don't know the basics of Bellman-Ford, you won't be able to understand this question at all. So it is better if you go to the video of Bellman-Ford and figure out how to solve it or what is the algorithm all about. Now, assuming that you watched it, we are going to move forward. Okay, so how does Bellman-Ford help us to solve this question? Basically, Bellman-Ford can never work with negative weight cycles. You cannot figure out the shortest path for a negative weight cycle. Reason being, see, over here if I want to find out the shortest path between 1 and 2. Okay, here we have 2, we can see this. Now move in a circle or a cycle. You see 2 plus 3, 5, -4, 1, -5, -4, and +2, -2. So you get -2 as your answer. If you go in another cycle, no, you will get an even smaller value, then smaller, smaller, and smaller. So what happens is you need to move in infinite cycles to be able to get your shortest path. Alright, so this creates a problem. So what Bellman-Ford does for us is that as soon as it comes across a negative weight cycle, it will detect it and tell us that, alright, this is a negative weight cycle and I don't know how to work with it. So it will detect it for us. Okay, so when we are working with Bellman-Ford, we go for V-1 iterations. The reason behind using V-1 iterations is that you need an optimal solution or an optimized solution. When we work with cycles, you can never get an optimized solution. Okay, so we take V-1 iterations so that you can get an optimized solution. Now when we will work with V-1 iterations, if you have a negative weight cycle, in that case it will be rejected by Bellman-Ford. Okay, and if you have a positive weight cycle, then it will work linearly only. So you will get your optimized solution. Now we also know that the maximum path length according to Bellman-Ford is equal to V-1. Alright, but when you are working with a negative weight cycle, the path length can become V, V plus 1, V plus 2, and up to so on till infinity also. See how? If you need to figure out the path between, shortest path between 0 and 2. Okay, so if you go in a cycle from here, you will see 1 plus 2 plus 3 -4 -5 and +2. So what will be the answer? Let's see. 6 plus 2, 8 and -9. So 8 minus 9 will give you -1. Alright, and then If you go in another cycle after this, you will get -1, then +3, -4, -5 and +2. So what will be the answer? 5 minus 10, that is -5. So you will get -5. Then if you go in another cycle, you will get a smaller value and it will keep on happening. Okay, it will keep on decreasing the value as and when you will go into a cycle. So you need to take infinite cycles to be able to get your shortest value. Okay, so what we will do is that using Bellman-Ford, we will take v minus 1 iterations like we normally do. Okay, so this will update all the values. Then we will go for a vth iteration after we will exit this loop. Alright, and from the vth value we will check that is my value getting updated. So if the value is getting updated in the vth iteration, suppose it is getting updated, so that means that a negative weight cycle exists just like we discussed. So you will return 1. And if you do not get an updated value, if it is not possible to update the value, it means that a negative weight cycle does not exist. So you will return 0. That is what you have to do in this question. So we will now work with it using code and we will keep on discussing it side by side. Alright, so I'll just make it full screen. Okay, so the first thing I need to do is create a vector array, right? So vector of int paths and the size will be n. I'll fill this with -1. So for int I equals 0, I is less than n, I plus plus, we will put path of I equals to int underscore max. Okay, and we also need to put path of 0 as 0 only. Then we will go for the loop, that is v minus 1 iteration. So for int I is equal to 0, I is less than n minus 1, I plus plus. Then for int j equals to 0, j is less than edges dot size j plus plus. We need to figure out the two vertices and the weight between them. So int u edges of j comma 0, then int v equal to edges of j comma 1 and int weight is equal to edges of j comma 2. Okay, then we will check that if path of u is equal to infinity. Alright, what will happen? You cannot update infinity, so you will simply continue, you will not work with it. Okay, otherwise you will check that if path of u plus weight is less than path of v, that means we can update this value, so we will update it. So path of v will become equal to path of u plus weight. Okay, now this we have done for v minus 1 or n minus 1 iterations. Now we need to work for the nth iteration also. So we will paste this loop over here. Okay, this will be my vth iteration. And over here we will check whether the value can be updated. If it can be updated, you won't update it. You will simply return 1, because if the value is being updated, we discussed that it means that it is a negative weight cycle. So we will simply return 1. If it is not updating, that means in the end we will return 0, because that means that a negative weight cycle does not exist. So now let's try to run this. Okay, now we will submit it. Okay, so we made some kind of mistake. Let's check what we've done. Okay, let's see. So we need, it is still wrong according to me. We'll check. So, alright, so what we did wrong was that we put a single equal to over here also, so it was not able to check. It was not able to compare the values. Now we will submit this. And now it is correct. Alright, so our mistake was that over here in both of these conditions, we put single equal to instead of double equal to. That's it. Otherwise, your code is completely correct. So we discussed about negative weight cycle detection and we used Bellman-Ford algorithm to implement it. I hope you were able to understand the question as well as solution. Alright, so keep practicing. We will see each other the next time. Till then, like, share and subscribe to the channel. Thank you.